right, so the next one is an alternating series test. Theorem 9.14. Alternating series test. Space over here. Make sure no one else waiting. Now we're good. Okay. So let AN, the sequence AN, be greater than 0. The alternating series goes from 1 to infinity. Has a -1 to the n of a sub times a sub. And it could also be written this way. N equal 1 to infinity. -1 to the n plus an. So you have some sequence. So remember, these could be any sequences we've already talked about times an alternating component. You see how these pieces force it to alternate, right? It could be anything. So they converge when these two conditions are met. Number one, the limit of a sub n as n goes to infinity is equal to 0. Number two, when an plus 1 is less than an for all n. Okay. So this right here is called, well, I guess we'll get to it in a second.
So are we skipping 9.4?
I think we did 9.4 already. Let me check.
Yeah, we did that last class.
Nine four was comparison series. What's that?
I don't see it on my note, but so 9.3 was integral test and P series test.
Right. 9.4 was comparison tests.
Oh man, I don't know what I put those notes. Okay, it's all right.
Guys, did I send you guys the notes? 9.4. Hopefully, if I didn't send it to you, let me know. Okay. I was wondering if you got the Canvas message. Things are a little more difficult since I'm here. Like, I don't know where the files go. I gotta make sure. So sometimes I forget. I have to wait till the next day. I'm not gonna, drive home and email you guys at midnight. But I'm gonna go to sleep. sometimes I forget on Tuesday or Thursday. I'm always paranoid. Shit. No. Let me check my. I have 9.4 scanned. I don't know. Maybe I haven't sent it. Yeah, here it is. I was scared of that. Didn't scan. Okay. Let me check one thing really quick from the book. Right. No, I would recommend you put them all on the corner of the page. Okay, my professor made me memorize them. It was not cool. I prefer you know how they work and when do you use them. I want you to learn that. I won't force you to memorize stuff. I don't believe that's what math's about anyway. It's not history. It's more about why does this work and how does it work. Okay. So determine the convergence or divergence of so we just need to check those two conditions. But notice that they don't at all ask you to check an alternating piece, right? Just look at the AN. So our AN sequence part is the 1 over n, right? So is the limit as n goes to infinity of 1 over n equal to what? I'm checking number 1. It is indeed 0, correct? So we're good. Now check number 2. Is an plus 1 less than or equal to an? Meaning, is it decreasing, right? Well, is this one? Well, actually, let me prove it to you. Do you agree that n plus 1 is bigger than n, right? So if I take the reciprocal, then I know for sure this is smaller, right? So yes, number 2 is good. So therefore, the series converges. Pretty easy idea, right? You just check. Is limit 0 and is it decreasing? If so, this is enough proof to determine it converges by the alternating series test. Sorry, spaced out. All right, so any questions on this? Is that okay? You want to do one more of these or should we move on to the next thing? Is this more? Go on this page. All right, no rush. Oh, wait. Go to the restroom real quick. Use some time. Okay, let's do the next example. Example 2, determine convergence or divergence. All right, so we only look at the sequence. And we determine it is the limit 0. So that's number 1. First thing we check. Yeah, right. And it's going to be 0 for sure. Now we check is AM plus 1 less than AM. Well, I know for sure 3n smaller than 3n plus 1. But to make it more concrete, we can factor that out as there's 3 of them, right? So now for sure, that one is less than, because it's 3 times as big, right? Okay. Now I take the reciprocal. And this one is decreasing. Yeah, so we're good. Number 2. So the series converges I'll put a little more detail this time because it satisfies both conditions of the alternating series test. Is there any questions on this example?
Number 1
Hmm.
is 1 over 2, 1 over 3n equals 0.
Yes. Why?
Yeah,
So when n goes to infinity, the denominator is getting super large. Right? The 3 to the n is a power function. So it's going to be 3 to the infinity. So that's going to get really small, really quick, because when the bottom of a fraction gets big, the decimal gets tiny. The bigger the fraction, the smaller the number. Eventually, an infinite small fraction is 0. Plus, the 1 doesn't do anything, right? So it's just 1 over. Whenever you have 1 over infinity, you can pretty much say it's another way to think about it. All right. Any other questions on number 2? Okay, make sure everything's good. Determine the convergence or divergence of the series -1 to the n plus 1 times 2n plus 1 over 2. Actually, let's make this a -1. So an will be the 2n minus 1 over 2n plus 1, right? So number 1, let's check the limit. You should always check the limit no matter what task you're doing, because remember how we said if it's not 0, then no, automatically it's going to be divergent for the other types. For alternating is a little different. So you take this limit, you see how you're going to get, see how that's the same degree, right? You're going to end up with 2 over 2, which is 1. So these overpower each other. These don't matter. So this is not 0. So right away you can say diverges. So the series diverges because the limit of an is not 0. By the alternating series tests. Yeah, that's fine.
But then you- this is 0.
It has to be equal to 0, otherwise it doesn't satisfy number 1.
Over 3. This is 0. So,
Which one?
the one is just left.
Number 2?
Number, yeah, number, you know, I mean, 55 1 over 3. 0.32.
Well, for this one, well, hold on, think of it this way. So for 1 over 3 to the n, this picture having a large number. That's it. Who cares what number it is? So it's 3 to the, like, why did you have a 100,000, right? It's too big, too big. Right, see how it's really tiny, right? So when n goes to infinity, this whole thing is going to 0 because it's shrinking it. On this one, they're the same degree, so they're both going to infinity at the same rate. So they basically cancel each other out. So the only thing they leave you with is the coefficients. If the degree would have been bigger on bottom, this thing would have gone to 0. If the degree would have been bigger on top, this thing would go to infinity. They're the same. We look at the coefficients, divide them. I think in Cal 1, we showed our work by dividing each one by the highest power. Do you remember? And then we ended up with two minus 1 over n over 2 plus 1 over n. So then these would go to 0, leaving me with 2 over 2. So what we used to do when we first got to the beginning of calculus 1. But after a while, we started to notice that when they're the same degree, just divide those numbers. Don't worry about it. You don't have to show this anymore. Unless you want to. You guys good on this page? Let's move on to the absolute convergence theorem. We're going to use this so that what we just used, and we're going to use it combined with this one. Absolute convergence. So on this one, what you do is you take the absolute value of the series to get rid of the alternating piece, and you just examine what's left. And if that converges, then you're good. If it doesn't, then we have to go check those rules, those conditions. So if the series of the absolute value of a sub n converges, then the series of a sub n also converges. Here's the definition of absolute conversion. Definition of absolute and conditional convergence. Number one, the series of A sub n is absolutely convergent when the absolute value of that series converges. That's what I was just saying. If this one converges, then the original is absolutely convergent. So the alternating piece doesn't matter. Okay. Now, if it doesn't absolutely converge, then it could conditionally converge. So the series of A sub n is conditionally convergent when the series A sub n converges, but the series of A sub n diverges. So this is the absolute definition, and this is the conditional definition. Okay, so basically, you know how earlier the last two examples, right? We checked those two conditions, and then it converge or diverge. So now what we're going to say is we're going to take the absolute value and examine that first. If that converges, you're done. But if that diverges, then you go and check the conditions after. Then you'll have a conditional convergence instead of absolute. But what you want, you're hoping for this one because then you're done. This is when you have to do extra work. Okay. Determine whether the series converges absolutely or conditionally. Or if it diverges, I guess, still an option. Wait a bit.
Number 5, 5. 5n or?
Yeah, 5 to the power n. Correct. So remember, to use the absolute conditional convergence, you got to take the absolute value of a sub n, or examine the series, right? So what we are really looking at is this guy. So if that converges, then that means this one absolutely converges. We're done. No, we don't do anything. So let's look at this guy. What kind of series is this? Looks like it, but it's not. If it was n to the fifth, then yeah. See, this is one of the first ones we ever did. First or second.
You understand?
That's right after. Like if you were to expand that, it'd be it'd be 1/5, and then 1/25, 1/125. Right, those types are called geometric, right?
Oh, yeah, when they do that.
Does it have the same factor in common? So this is a geometric series. So since let's just save space here, is geometric, and R is equal to 1/5, which is less than 1. Remember, we said that was a requirement. Then the absolute value of a sub n converges by the geometric test. Therefore, the original converges absolutely by the absolute convergence definition. Any questions on this one? But not too bad, right? You just take absolute value and then figure out what test works. And if it converges, then you're good. If it does not, then you're not good. But let's do one that is not absolutely. You guys cool on this page? Example 5. Same instructions, determine if the series is absolutely convergent, conditionally convergent, or divergent. All right, so the absolute value version of this is equal to this guy. What test would you use on this? There's two that I can see will work. Integral would work, but there's an easier one. So what's from last time? Remember the direct comparison that would work. Maybe limit too. I think. That's good. Yeah, let's do limit comparison. That one looks kind of easy. So for the absolute value guy here, let AN equal the original, of course. What is a good B sequence piece of that to compare it to? I mean, remember, they have to be similar. Do you remember? Also, it helps if you know what it's doing.
This is algebra professional stuff.
Yeah. Let me make a note up here before I write that. What do you guys think? Good. We had something like this before. Remember, we would just choose it without the number. So all we have to do now is take the limit as n goes to infinity of an over bn, which is going to be 1 over n plus 2 divided by 1 over n, which is n plus 2, or n times, skip steps. 1 over n plus 2 times n over 1. Now let's take the limit. So that will be n over n plus 2, which is equal to 1. Right? So since the limit of an over bn is equal to 1, then both series converge or diverge. That was a requirement of the limit comparison test, right? And we need to know what the one of them does. So we know this is a divergent P series. Then, sorry, since the B sub n is a divergent P series, then the series of A sub n diverges. That doesn't tell us anything about this guy, the original, right? It just tells us, so this conclusion means that it is not absolutely convergent. That does not mean that it diverges. You see what I'm saying? So we got to check, okay, maybe it conditionally converges. If it's neither absolute nor conditional, then you can say diverges. So the alternating stuff makes it harder, basically. So this means is not absolutely convergent. So we must check the conditions. So condition 1 is the limit of a sub n equal to 0. It is, right? Number 2 is it decreasing? N plus 2 is less than n plus 3. So 1 over n plus 2 is greater than 1 over n plus 3. Right? If I do n plus 1. So yeah, as this gets bigger at the bottom, it will decrease. So therefore, the original is conditionally convergent. But not absolute. So this crap over here told us wasn't absolute, right? This told us it was conditional. If it would have filled both, then you can finally say it diverges. Any questions on this problem? You see why you want it to absolutely converge, right? Otherwise, it's annoying. Yeah, I think the conditional case is the most has the most work, but absolute is pretty quick. But diverges, if you notice, right? If this limit would have been something else, like if you would have seen it up here, like let's say you saw ANs right there, if you would have seen that that's not going to be a zero limit, you could have just said stopped all this and just say, you know what, diverges because it's not zero. Remember the first test I showed you, the divergent test? That's why I always mention, like, look at the limit before you start of the sequence. If the limit is not zero, then none of this is worth doing because you already know the answer. Just put buts, put the word numbers. That's it for 9-5 pretty much. Good night. You guys good on this page? Nine point six. The ratio and root test. There's two more tests here. I don't know how many we've done already. talk about the ratio first. The series of a sub n be a series with non-zero terms. Number one. The series of a sub n converges absolutely when the limit as n goes to infinity of the sequence of am plus 1 over an is less than 1. So you take the, so you have a ratio, you have a series. You take the sequence part, add plus 1, divided by the original, and then you take a limit. If that limit is below 1, then it's absolutely convergent because it also has a built-in absolute value. 2. You can also say the series diverges when the limit as n goes to infinity of am plus 1 over an is greater than 1 or infinite. 3. The ratio test is inconclusive, meaning you have to use a different test when the limit then goes to infinity of am plus 1 over an is equal to 1. So if it's exactly 1, then this test doesn't work. Okay. Let me write down the root rules before we start. They're similar. A root test. Number 1. The series of a sub n converges absolutely when the limit that then goes to infinity of the nth root of the absolute value of an is less than 1. So see how it's very similar rules, right? It just has a root on it. This is the nth root though. Okay. Number 2. The series a sub n diverges when the limit then goes to infinity of the nth root of a sub n is greater than 1 or infinite. The root test is inconclusive when the limit of this same root test here nth root. The absolute value of an is equal to 1. So let's right for a second. Press my hand. I noticed like 2 weeks ago, like just at home, it was like on the weekend. Man, why is my hand cramping so bad? Couldn't figure out what could have messed up my hand, and I realized, oh, I write all the damn time. But usually I don't have any pain, but I think I haven't had like any breaks. That's when I start to notice. But yeah, then I guess I'm getting older too.
I used to crochet a lot.
Yeah.
Every couple of years, you just have to wear a brace for a month or two. Nothing major, just like give it a break.
I used to do a lot of PC games. My hands were all messed up. I haven't done that much anymore. But now it's coming back with the writing. I was playing like World of Warcraft first came out, and Final Fantasy 11, a bunch of MMOs back when I had free time. Now I just play console game, controller once in a while. Yeah, the controller's nicer, less. Yeah, it's hard. Usually I do that like late at night before bed, for an hour or something. If I get home early, then yeah, a couple of beers and play a game or something. We'll see how I feel tonight. I like these tests because they're not too hard to use. You see how you just divide the AM plus 1, right? It's not a big deal. I think my personal favorite is the root test. When it's appropriate to use, it's really easy to use. The ratio, you want to use that whenever you see a factorial. Basically what I mean is, if you see a factorial, the only way to do it is a ratio test. But you could do ratio tests on other problems. But for sure, those types. A root, well, when you see like an power to the n, like remember how earlier it had like 1/3 to the n or something? Like you could have used a root on that guy right away, and the n's would cancel, and the limit would be 1/5, right? Which is less than 1. So converges and you'd be done. Right, oh, sorry, here, this one. Well, you gotta first understand absolute convergence before we get there. You guys cool on this page? Okay, let's keep the problem here. Let's start with the ratio. Would you crochet or knit? We're reading about the prisoners in Alcatraz. They all became really good at crocheting. Yeah, they're just everything else. They're like, yeah, they were just pros. A bunch of like Acapulco and all the weirdos. Nice. Yeah, I mean, I guess if I ever go to prison, someone would do. Yeah, I see like on the internet, they have like little like like, I don't know, I got action figures are like a doll, I guess, like little figures. I guess they're like full of, I don't know, they're full of beans or they're full of like this fluff, like little dolls. They crochet. Pretty cool. Greater divergence of well, that one guy, right? Maybe. Never found him. So either he drowned or he escaped. But those bay waters are no joke.
He looks swimming, but he gotta be trained. You know,
Yeah, I don't think I'd make it to the bay. I don't think I can do the doggy paddle for 2 miles. Dive exhaustion. Factorial. So this is a factorial problem. So basically we have to use ratio. Since we're just learning it, I'm telling you, you should use ratio. Remember we said we need the AN. And we need the AN plus 1. Right? Then we do the ratio, the test. The limit as n goes to infinity of AN plus 1 over AN is equal to the limit as n goes to infinity of 2n plus 1 over n plus 1 factorial times I skipped a step. Cool. Divide and flip them over. I don't know why I put 2 absolute value bars. I mean, it's not wrong, but it's very unnecessary. Everything is inside absolute value. Now notice that this stuff can cancel out. So let me show you. 2 to the n times 2 is the same as 2 to the n plus 1. Times n factorial, so that's right there. So I'm just combining the fractions, and then I broke this piece up here. N plus 1 factorial, that's going to be the same as n plus 1 times n factorial, right? Maybe we can expand it a little bit and then stop. There it is. And I did that on purpose because we're going to cancel these and these. So after we do all that algebra, I guess, witchcraft, it's going to be 2 over n plus 1. What is the limit? Okay. There's an n on the bottom. Yeah, goes to 0. So since the limit of an plus 1 over an is less than 1, then the series of a sub n, the original, this one, converges absolutely. That's it. Any questions on idea.
It's on the one, the second one. It's AN plus one. The first one, not
Yeah, an plus one over an. So that's why
AN.
I did the plus ones here. Is it making sense? Let's do another one. One more ratio. Use a ratio test to determine convergence or divergence of this guy here. All right, so AN is going to be this guy. The alternating piece doesn't matter because there's an absolute value built in, right? So take the limit of this guy. An plus 1 over an would be equal to the limit of this guy first. Here. All right. So let's show the algebra here. Two times 2 to the n over n plus 1 squared times n squared over 2 to the n. These will cancel, no problem. These I need to expand a little bit so you can see it better. So up here I have 2n squared, right? If I multiply this out, I'm going to have n squared plus 2n plus 1, right? You take that limit, what is it? Yeah, the same degrees, right? So you take the coefficients, it's going to be 2 over 1, which is 2. Technically, you could have brought the alternating piece along for the ride, but absolute value takes care of it. Mathematically, it's okay not to bring it. All right, so this is greater than 1, isn't it? So since the limit of, I don't know if I wrote it like that. Whatever. An plus 1 over an is equal to 2, which is greater than 1, then series an diverges by the ratio test. This one's an actual function. Yeah, my police officer friend, he's like, "Yeah, a lot of them are just either they're taken by a parent that should not supposed to have them. Like, dad's like, I come with me, and then no, you're not supposed to have them this week. There's an argument. Most of the time it's something like that, or sometimes a runaway and they won't come home. But once in a while, it's they're taken. So it means we get more details. Or they're taken and they have no details, which is even worse. It's like a nightmare situation. Any question on number 2? For ratio. Now let's go to root. Root's pretty chill. Yes, on the page. Use a root test to determine convergence or divergence. So AN is just this piece, right? Sequence. That is n to the n, by the way. Now it looks weird. So the root test says you take an nth root. Base of n, absolute value. Absolute value just, well, it doesn't really make a difference here, but just know that we took it. And we know that these roots can be written as a fractional power, right? And if you have power on both, you can separate it onto each part, right? Notice how these will cancel here, right? They're using the rules of exponents. You guys remember from algebra 1? So I cancel on the ends. Now take the limit. What's the limit going to be? Yeah, 0. So since our conclusion, the limit of the nth root of a sub n is equal to 0, which is less than 1, then the series absolutely converges. Pretty much it for the root. I guess we're gonna do one more. We'll do one more root test. Use the root test to determine convergence or divergence. So the limit, I'm gonna use the 1 over n just to save us time. There, right? You know what I mean? So these will cancel, and absolute value is not going to do anything. These are gone. So we get the limit as n approaches infinity of 3n plus 1 over 2n plus 1, which is 3 over 2, right? Which is greater than 1. So since the limit of the nth root of an is equal to 3/2, which is greater than 1, then the series diverges. Your test is pretty straightforward, right? Ratio is 2, but there's a little extra algebra in there. They're very similar when it comes to the rules. So the test is due Wednesday night. You guys need a little more time? You need more time? Yeah, that's not a big deal. Just know that chapter 9 is ending. That means test 4 is coming. So I don't mind putting it for Sunday night or whatever. Okay, just know that. Make sure you get some chapter 9 stuff done. Otherwise, you'll be in trouble. We'll stop here. You guys have any questions?
No, thank you.
All right, guys. Well, have a good night, and we'll start again on Wednesday. Yeah, close this room.